Okay, good afternoon, ladies and gentlemen. I'm glad to be here today with you and to share with you two successful stories of implementing the machine learning at the edge of Saudi Aramco, the plant of Saudi Aramco. A few years ago, Saudi Arabia has launched a new vision, Vision 2030, with an objective of creating an ambitious nation with a vibrant society and having a diversifying economy, a thriving economy that is moving away from the focus of the oil as the main source of income into having a diversified economy. And in line with that, Saudi Aramco have created a Vision 2020 with the objective to move from being an oil and gas company into the largest global energy company and to be the #1 employer in the world and to have a leadership in the technological development. So we want to move away from being a technology consumer into being a technology producer. And all of this is to drive the Saudi economical growth and to lead the technological development with the focus of the in-kingdom total value added program or initiative, ICTIVA, which has the objective of localizing the industry and the technology development and to add as much local content in Saudi Arabia as possible. One of the main components of this vision is the digital transformation. And the digital transformation of Saudi Aramco, the strategy, cover the end-to-end value chain of Saudi Aramco, going from the IT, OT, all the way to the HR, covering all the aspects of the digital transformation. And what we will focus on in this presentation is the Iot Convergence. And the objective that we have within the Iot strategy is to create solutions that are expandable, cloud-based, that can be expanded to all operating facilities within Saudi Aramco and with the potential to commercialize it to our joint ventures and the external entities. So this is the Purdue reference architecture that I'm sure that most of you are familiar with, and this is what we mean by the Iot convergence. If we look at any plant, despite the industry that we are working on, whether it's oil and gas or pharmaceutical or food industry, we will see that the plant has equipment or assets that are controlled with controllers, connected with the actuators and sensors, and controlled through the process control system, be it DCS, SCADA, and whatnot. So these level 0, 1, and 2, are what we usually call the industrial control system or process control system. And between those two levels and the enterprise resource planning, where we are managing the enterprise equipment and resources, there resides the layer 3, which is the manufacturing operation management, or what we call in Aramco the integrated manufacturing operation management system. Recently, a 5th layer was added to include the cloud, where we are accessing the information from the center of excellence that are available outside the premise of the company. What is the challenge of this model? Any idea? Okay. The challenge is protecting and moving the data from one layer to another. As you know, the layer here is the control system. Everyone wants to keep the plant secure from external attacks. So usually they put firewalls or demilitarized zone to segregate the network between the plant and the enterprise within the company. In addition, another layer of a protection between the company itself and the external entities. So for moving the data from the actual data source all the way to the enterprise layer, all the way to the cloud, usually we lose some of the details of this data. The fidelity of the data gets shrinking, and the latency. Moving of the data will take a large amount or a long time of moving the data from one layer to another. So how is this related to the machine learning at the edge? If we look at the current data analytics model, we usually take the data from the data source And we go all through all the layers, the 5 layers, to send it to the cloud, and then we do the data analytics and send it back to the controller. The advantage of this model is that we have a centralized support, subject matter expert or center of excellences that will help us in doing the analysis and helping our operators to set the set points of the controllers to achieve the ultimate goal. The disadvantage, though, that it will have a high cost of establishing these different layers. The latency is huge, and most importantly, we are exposing our network to a high security threats by connecting it to the network. And this, what drives the industry to move the analytics to be closer to the data source. So instead of pushing the data all the way to the cloud, we are moving the analytics to be closer to the data source, where we can do the initial analytics, the initial analysis, and do the control. And in the same time, we can still continue to push the data to the cloud to do further analysis. So the advantage of this model is that we have a low latency. It has a very low cost. As you know now, the chips that might cost us from $5 to $30. And we can go with a faster decision. The operator will be empowered with the data to make a faster decision. The disadvantages that we will speak about in details later in the technology, in the presentation, is that we have different standards. Usually the edge analytics, they are either Linux-based, and they are based on container, not the normal or traditional way of developing the application. And sometimes when we keep the data closer to the data source, the enterprise and the cloud will have a lack of visibility on the data or what's happening in our plant. So to give you more advanced details of the difference between the edge and the cloud, as you can see here, we are processing gigabytes of data in the edge as opposed to megabytes of data in the cloud. So what's the difference? If you see, the level of details that we are getting into the data here is huge. And especially if you want to train the model of the machine learning, the more data that you have, the more accurate and precise your model will be. So if you look at the fidelity of the data, we have higher fidelity. It will help us to have a higher data quality. And it will help us to identify if we have, for example, a problem with analyzer, we have data spike or whatnot. If you see here, between the two diagrams, we cannot tell if it's really the actual operating condition or it's a data spike. But by having all of these data, we can really tell if it's a false positive or false negative. And based on that, we can have a faster response and better decisions. So as we spoke, the main drivers of the edge analytics is that in most of the plants, especially with the data segregation, we have either limited or no connectivity with the outside world. The bandwidth and the cost of moving the data is huge. And most of the times, we have the risk of cyber attack, especially when we open it to the internet. The latency and the real-time decision-making is significantly impacted by having these different layers. And by having the edge and having the data closer to the data source, we have high-fidelity analytics or streaming of data. So if we look at the technical and economical benefit of each model, the real-time streaming of the analytics, it gives us high fidelity and better prediction. So it will help us to make timely decision, and which will help us in reducing the downtime and the maintenance cost of our assets. Talking about the iterative machine learning and the deep learning, we do the analysis on the edge so that it will help us to do a faster decision, and we can continue to send the data to the cloud to do further analysis. This will help us to have a continuous asset performance management and tuning, which will maximize our performance and the yield of the plant. When it comes to the optimization of the infrastructure, we are using the local data. So instead of building the cloud and tapping into the cloud and establishing the cloud, we are here having those cheap chips that we are using for doing the analytics, which usually reduce the initial investment of establishing the cloud up to 90%. The security, of course, we are reducing the reliance on the internet. We can manage and we can do all of our decision making based on our local resources and without even exposing the data to the corporate network, not the internet, the corporate network of the company. It will help us also to enhance the compliance and reduce the fine, especially in our case where we are talking about the flare monitoring. One of the things that we discover is that when you empower the operator to make the decision, they have the ownership, or they have the sense of ownership of managing this application. When you ask them to give the data, you take them to the expert of the Center of Excellence. The Center of Excellence will send the recommendation back to the operator. The operator will not feel that he owns the system. So usually, these systems will die for natural causes later on. But when you empower them to make the decision, they tend to have the ownership of the system, which will increase the total value of ownership and reduce the cost of ownership. Last but not the least, most of these edge computing technologies are based on subscription-based. So you pay per use as opposed to the normal software where you have to pay for the license and then annual maintenance fees, which will cost you a lot of money to maintain just the software without realizing the benefits. So in our case, to pilot and to prove the concept of the edge and the analytics at the edge, we took two use cases. One is using structured data, or normal data, and one is using unstructured data. Unstructured data, we mean the images. So we are doing image and video analysis. We take the sounds and the alarms, and based on that, we model the machine learning to help us in monitoring our flare in Saudi Aramco. So this system, I'm sure that you know about Saudi Aramco investment and reducing the footprint of the hydrocarbon. We are spending so far more than 1.2 million to minimize the hydrocarbon footprint. And we have implemented a corporate flare monitoring system that is commercialized, and you can use this system to help you to reduce the flare. In our case, we have the published benefits and the World Bank, and you can all have access to the benefit that we have from the system. So to complement this system, we have used the edge computing, where we are looking at the non-traditional type of data. The system that we have is based on the traditional data, where we are using the real-time monitoring of the valve and how much we are emitting to the environment. But in this case, we are looking at the flare itself, looking at the size of the flare, the angle, the size of the smoke, and other parameters like the temperature and the chemical combustion. And based on that, what we do is that we, based on the size, the smoke flare, and the angle, the system will detect that we are violating the regularity compliance that is set by the APA. So mainly, any violation, as you can see here, if we have the ratio of the smoke is more than the fire, then the system automatically will detect this violation. The technology or the mechanism that we used is the convolutional neural network. As you know that the artificial intelligence go into the machine learning and the deep learning, and the convolutional neural network is good for the unstructured data. It's very good for image processing. It takes millions of parameters to train the GPUs. And mainly it has all these layers. It will take all of these layers and to segment the picture. And based on that, it will come up with a fully connected layer with a binary classification. So this is the final result. As you can see here, it was built using the Foghorn Edge Analytics, and it is container-based. So what they do is that they will look at the flare, and based of any violation, as you can see here in the dashboard, it will highlight that we are moving away from our threshold. Another example that we did is to detect the moisture in the flue gas. And what we did is that in this case, we used the random forest, which is good in the time series data. And mainly what they do is that we take all of the take flow rates, temperature, and pressure, and use the model to be a soft sensor to predict the moisture. And as you can see here, the blue is the predicted moisture and the orange is the actual moisture. And you can see they are lining up accurately and perfectly together fine. So the mechanism that we use is the random forest. And as Valentine mentioned, this is based on the decision tree and it has so many decision trees. The difference of random forest is that it goes with the best random feature as opposed to the most important features within the decision trees. One of the things that we saw and lessons learned from our pilot is that the container is the new way of developing the application, is a very fruitful and useful way of developing the application. It reduced the footprint of the technology. As you can see here, instead of having a complete operating system for each application that we have in the plant, we can have the Docker engine here, and we can install each application as alone, and each application can go and access the operating system kernel directly without the need to have an individual virtual machine for this. So if we compare the cloud-based machine learning versus the edgified machine learning, as you can see here, the comparison is huge. So if we talk about the model size, in the cloud, it's 62 megabytes versus 25 megabytes of the edgified machine learning, where we have 4 times improvement. The runtime memory that is needed for the cloud is 1 gigabyte, as opposed to 100 megabytes for the edgified machine learning, 10 times the improvement. And the processing frequency for the cloud, 5 minutes versus 1 second in the edge computing. So the lessons learned, to conclude, the lessons learned of our 2 pilots is that the edge analytics will help you with specifically with the unstructured testing, the unstructured data that you have within the plant. It will give you a meaningful analytics. The open data sources, the open data scientist environment, Python or the R, combined with the Docker container are very powerful tool, especially for the artificial intelligence and the edge computing. The industry needs to move from the traditional way of developing the application, this was mentioned this morning, into the new way of the containers and developing the Linux-based environment. The challenges that we have specifically with the brownfield plants is that they are still using the traditional and legacy standard like OPC DA, the direct access, as opposed to the UA, unified access. One interesting fact that we found is that when you look at the flare during the day and you model the machine learning is entirely different when you look at it in the night. So you cannot use the same model that you have in the morning or during the daytime in the same time, in the same way that you use it in the nighttime. And you need to have 2 models, or you fine-tune the model accordingly. And with that, thank you for listening. I will be more than happy to have your question later on.